Hey, we continue doing trigonometric ratios and I pick up easy medium questions for now. So the main goal is to find a known angle, so that's why one type of questions. Okay, so make sure you watch the previous video where I explained the trigs basics. That's definitely foundation for everyone, where I explain the fast track how to which sort of trigonometric equation to pick up, okay, depending on which side you are given. Okay, so in case you're given hype, you always need to use cos or sine. In case you're given only just opposite and adjacent leg related to the angle x, for example, you need to use always tangent or cotangent, but mostly we use in tangent rule. Okay, so make sure you watch that. If not, just go back to the foundation and then go to the medium, easy medium problems. And right now we're going to consider the first problem. You need to find angle x. Okay, mark on the figures right there. So pause the video, try to do by your own, and let's get started. Okay, so we've got an isosceles triangle. The idea of isosceles triangle allows us to say that if AK equals KC, as you given there, so K is the midpoint of the segment AC or of the base, and that's why BK in this case is the middle bisector of the segment AC. So that's why using the rule and using the theorems related to isosceles triangle, we can conclude that BK is perpendicular to the base AC. So that's why BK is the height. Okay, having height there, we can consider triangle ABK. So ABK is right angled triangle. So that's why using this triangle, I just shade it and put the angle 90 degrees. Okay, we can use the trig ratio in order to find angle x. Okay, so we are given the height, which is 25. We are given AK, which is the opposite side related to the angle, which is half of AC, which is 6 centimeters right now. So we can use the sine rule right now. So sine of angle x is going to be opposite to hype. Okay, remember the rule, if you have hype you always use sine or cosine. So in this case we just plug the numbers and we got the fraction 6 over 25. So that's why angle x automatically is the inverse sine function of the fraction 6 to 25. Okay, and make sure your calculator is in degree mode. So you need to ensure that degree button is like degree mode is highlighted on your calculator. Otherwise you'll get the wrong answer in radians, okay, not in degrees. Be careful about that. If you calculate that, you'll get 13.88, or if you round up to the nearest whole, it's going to be 14 degrees. Let's move next. So we are given a rectangle with sides given below. Okay, 15, 25. Pause the video, try to do by your own. Okay, and we try to solve. In this case, I think we can solve in different ways. I'll show you the way one. So way one. Let's consider triangle any, let's say BCD. So consider triangle BCD. So it's definitely a right angle, okay? And the idea is pretty straightforward. Let's find this angle because let's say this is y. This angle is going to be also y. Why? Because BD and AC are diagonals, right? And due to the fact of symmetry, they will arrange the same angles. And by the way, they're also split up. So that's why triangle, let's say point O, triangle BOC is an isosceles. So that's why from we can conclude that angles at the base are the same. So that's why we have two y's the same, okay? From triangle, we have angle B in that triangle equals to the angle C. So that's how we establish y and y, okay? And from triangle BCD, from the big one, which angle C is a right angle in this case, so we can express, obviously, angle y. In this case, we are going to use tangent because we are given 15. Let's say this side is 15 and the top side is 25, okay, due to the fact that this is a rectangle. So that's why angle tangent of angle y is going to be 15 to 25, okay, or as the same as 3 over 5, it would cancel. So from there, we can express angle y itself, okay? So using 10 minus 1 of the fraction 15, or 3 over 5, or 15 to 25, okay? So we've got 30.96, so 30.96 degrees. We're not going to round at this stage because we rounded at the final stage when we found angle x itself. Okay, so from the triangle BOC, we can conclude that angle x is going to be equal to 180 minus 2y, okay? So this is the way. And so we multiply by 2. So let's multiply by 2. I've got 61.92 and subtract from 180. So I've got 118.07 degrees. If I round up to the nearest whole, it's going to be 118 degrees, okay? That's an obtuse angle. Okay, so way 2. So using the way 2, we can actually consider the half of the triangle. So let's put this line from there. So in this case, okay, I'll show it this way. So if I put perpendicular, but I put it down, yes. So obviously I will have angle x over 2 here. So this angle is going to be x over 2. All right, so angle x over 2, because again we have isosceles triangle AOD, we put the height, right? And it's also middle bisector, so that means those bottom sides are the same. So if we consider triangle AO, let's say L, so using triangle AOL, it's definitely a right angle, as we notice that OL is the height for that. So we can express x over 2 immediately because we know that that side is going to be 25 over 2, which is 12.5. Okay, and we know also that side because it's 15 over 2. So remember that splitting point for the diagonals means that if you put a line, it splits rectangle on 2 equal rectangles in this case. So that's why we will use this fact and say that that side OL is simply half of 15. So it's going to be 7.5. Okay, we have two sides and an angle. So we have opposite side right now, which is 12.5 related to the angle x over 2, and 7.5, which is adjacent, okay? Put adjacent side, okay? So that's why we arrange tangent of x over 2, which is simply 12.5 over 7.5. So opposite over adjacent. From there, we can express x over 2, which is simply 10 minus 1 of 12.5 over 7.5, okay? So we use 10 minus 1 of that. And what I've got 59.036. Okay, now I times by 2 simply, okay? Times by 2. And I'll get, of course, the same result, 118. So x from there is 118. As you can see, the same result that you can obtain two different ways. And let's move to the last one, okay? So we have triangle ABC, so that's the triangle. And this triangle, this is a right angle, so angle B is right angle. BL equals LC, so BL and LC, they're both by 6 centimeters, so that's why I can put 6 centimeters as well. And AB side, bottom side, okay. Yeah, so what we're gonna do, we need to find angle X. Okay, so what we can do, I think the best way is to say that if this small angle is gonna be y degrees, so we can find first angle X plus y using the big triangle. So the first case is to consider triangle ABC, which is a right angle. From that triangle, we can express, so that's opposite side BC, right? And AB is going to be adjacent. So that's why we're going to calculate tangent of y plus x. So that's the total angle A. So tangent y plus x is simply opposite to adjacent, which is 12 over 15. And now we're going to calculate 10 minus 1 of 12 over 15 right now. And it will gives us, so y plus x is going to be 10 minus 1 of that fraction is going to be 38, 65, so 66 roughly, okay. But now from the small triangle, let's consider a small triangle as well. So from the triangle that I shaded, BL, so this is triangle BLA, we can express angle y, so tangent of angle y is opposite, so in this case small 6 is going to be opposite and still 15 adjacent, so that's why it's going to be 6 over 15. And now we're going to calculate 10 minus 1 of 6 over 15, which is, so angle y itself is 21.8. Okay, and how to find angle x? Just plug y here and express. So angle x from this aspect, from this expression, is going to be 38.66 minus angle y, which is simply 21.8. Okay, so that's why finally angle x is going to be equal 38.66 minus 21.8. We've got 1686 degrees, or to the nearest whole, it's going to be approximately 17 degrees. Okay, so we accomplished everything there. So I hope you like that, and don't forget to also consider other more complicated problem involving trigonometry, involving trigs ratios. So here's plenty in playlist dedicated to medium and even medium hard level. If you're pretty confident with that, don't forget to visit 3D trigonometry problems. They might be even more complicated, okay? And don't forget to visit A-level Zillions classes, all right, for A-level stuff. Thank you guys. That was Daniel Dallas. Peace.